Hello everyone, welcome to the session of class 9 mathematics and I am your Anu from AXIOMS. It was introduction to Euclid's geometry we have been seeing for the past three classes, and last class I've explained to you about Euclid's postulates. We had 5 postulates and the 5th postulate is an important one which explains parallelism, and I have also explained you there are many other versions for the 5th postulate like Playfair's axiom, which actually states that there can be only one parallel line through a point not on the line to the previous line, isn't it? Now we'll still further see some of the axioms of Euclid, and these axioms are based on the line segments. They are line segment axioms, length axioms of line segments. So let us see what Euclid has to say about the length of the line segment. Now we know line segment, he called it as a terminated line because it has end points, isn't it? 2 end points. And the first one is the line segment length axiom. That is, a line segment has a particular length and it can be measured in meters, and that is what is represented by length of AB is equal to r centimeters, r being any real number. Okay, it can take any real values. So length of AB is equal to r centimeters. That is what he said in the length axiom. So there is a length in any line segment. There is a length for any line segment and can be measured in meters or centimeters. Now next is congruent line segment. We know what do we mean by congruency. That is, if we draw a line and we draw several other lines similar to the previous line, and when the lines are made to lie upon each other, they perfectly cover the line, that is, they are superimposed on the lines. That is, the one line is superimposed on the other line and it covers the line exactly. So we call those line segments as congruent line segments, and they can be represented as AB congruent to CD. This is the symbol for congruency. AB is congruent to CD. If I draw two lines AB and CD and they are congruent, which implies, what does it say according to the length axiom? When two line segments are congruent, then the length of the line segment AB is equal to length of line segment CD. Okay, so the length are equal. The lengths of two line segments AB and CD are equal when the two line segments are congruent. That is, we are able to superpose one line on the other and it covers the line, one line covers the other line exactly. Okay, so the congruent lines, if they are congruent, that the length of the line segments are also equal. The next is the addition axiom. So what do you mean by addition axiom? With respect to the length of the line segment. Okay, so what he said, addition axiom states that if there is a line segment, see, there is a line segment AB and there is a point on the line segment AB, that is not either that should not be either B or A or B. So the line segment has a point C and that C is not either A or B. It is neither A nor B but any point on the line. Then what the length axiom says, that is addition axiom, depending upon the, with respect to length, says length of AB, see, length of AB is equal to length of AC plus length of CD. Okay, so there is a point on the line segment AB and that point is neither A nor B, it is some point on AB. Then the length of AB, the total length of AB will be equal to length of AC plus length of CB. Do you understand? So this is the addition axiom. When you add both the parts, you will get the whole part. Okay. So next is construction axiom. So what do we mean by construction axiom? So depending upon the length, you have some dimension, you have some length to the line segment, and when we will be able to measure the lengths in the line segment, and he has given in his axiom, he has taken a particular portion of the line segment, and even that portion can be measured, or a portion of the line segment can also be recreated, can also be constructed. That is what he is coming to say. So in the construction axiom, we have a line L and there is a point O. Okay, if there is some point O on the line, then what does this construction axiom says? If there is a point O, and let us take some other points on either sides of the point O. If I take points on either side of O, let it be P1 and P2. Then what does the axiom say? Length of OP1 is equal to length of OP2 is equal to r centimeter, such that, see, the points are equally placed from O on either side. See, OP1 and OP2 are equal, and that is equal to r centimeters. So we can measure, or we can construct a part of the line segment from a line. A part of the line segment can be constructed when the measurement is known, or we can measure that part of the line and it is given in centimeters. Okay, where r takes any value, any real values. So construction axiom says a length of OP1 is equal to length of OP2, which is equal to r centimeters, where P1, P2 are points on either side of the point O. Okay, so the next one is the distance between points. So what do we mean by distance between points? We know the line segment has two endpoints, P and Q. If they are P and Q, so the distance between the points from P and Q, what is the distance between the points PQ, is nothing but the length of the segment, isn't it? The length of line segment PQ is nothing but the distance from P and Q. So that is what length of PQ, that is the length of PQ is nothing but the distance between the points P and Q. Okay, so the next is betweenness. So when we see about, when we see the axiom distance between 2 points, we also look into betweenness. Betweenness, what do we mean by betweenness? That is, in between the 2 points, that is in between the end points of a line segment, there is a point C here. Okay, so let it not be the middle point, or we can take it somewhere else, wherever it can be, but it lies in the interior of the line segment AB. So AB is a line, and the interior part of AB can be anywhere, so I have marked it as C here. Okay, so then if C lies in the interior part of the AB, then that is interior part of the AB means it lies on AB, then A, B, C are collinear. Naturally they are collinear, isn't it? Because they lie on the same line. So C is a point, we always stress on this, C is a point, it is neither A nor B, because AB defines the line segment, they are the end points of the line segment, and C is any point on AB, and it is neither A nor B. Okay, then we can say A, B, C are collinear. Okay, they lie on straight line, and then AB is equal to AC plus CB. So we have all, we have already done this, we have already looked into this in the addition axiom, isn't it? So the same thing, AC plus CB will give you AB. So that explains the betweenness of a point between the end points of the line segment. Then comes the midpoint. When we say betweenness, I said C can be located anywhere in between A and B, isn't it? So if that C is exactly at the midpoint, at the mid of the 2 points, 2 end points. So let us name it as M to be the midpoint of AB. Okay, so it divides AB into 2 equal halves. That M point divides AB into 2 equal parts, such that AM is equal to MB. So that is why we say M is the midpoint of AB. And if there is a line through M which is not AB, See, a line through M is this, and that is not AB, isn't it? So this is AB and M lies on AB, and there is another line through M which divides AB into two equal halves, is called the bisector of the line segment AB. Okay, what we have done in before classes, we usually draw the perpendicular bisector for the line, isn't it? It divides the line into two halves. So that is the bisector. So the line which passes through M, but it is not the line AB. Okay, so M lies on AB and there is another line passing through M, and that is called, which divides the line AB into two equal halves, and that is called the bisector of the line segment AB. So that such that AM is equal to MB. So that is two equal halves. So we say M is the midpoint of AB. So these are some of the length axioms of line segment which Euclid defined. So we know axioms are universal truths. They don't need any mathematical proof. They are taken as such. They are taken for granted. So axioms, but he observed these axioms to be true, Euclid. So he defined these as these set of axioms for the line segment. Okay. So we have seen today, we have seen some of the length axioms of line segment. In the next class, we'll see some examples to know more about, to have a still more deep insight into the Euclid's geometry. Okay, so until then, it's bye from Anu for mathschool.1. Thank you.